Hello, 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 and welcome to BC Calculus with Henry Lumbino. Today we'll be looking at 14.3, which is local linearity and the differential. So basically what this is we're now going to take entire equation, entire planes in 3 space, and we're going to find a tangent plane at a certain point, which is going to consist of doing a few things. So, alright, so we have problem number 3, find the equation of the tangent plane at the given point. So how do you do that, Henry? Alright, here's how. So, you know how normally when you're finding like the tangent line, you have to find the, you have to differentiate the equation, find the rate of change at a certain point, plug that in for slope, find the y-intercepts, la-di-da-di-da, yeah. So this is basically the same thing, except now with 3 variables, you have to do it a little bit. It has a few more steps that you have to add on. So here is the general equation for finding the tangent plane. Okay, so there is how you do find the tangent plane. So basically, you're going to and so you can see basically. So you solve for f at point f of ab. You solve for f of ab plus f in relation to x of ab times, that should be x minus a, plus f in relation to y ab times y minus b. So that's your standard equation, and you'll notice it's very similar. It's kind of similar to when we're just finding our standard derivatives for our standard lines in 2 space, where you have to find the derivative and use that as the slope because you're multiplying it here by the variable here. So you're basically finding 2 slopes here now. So let's start solving this problem. Okay, so we have f of x, y. Okay, no, I'm sorry. Let's get rid of that. Get rid of that. Okay, so we have z equals ey plus x squared plus 6. Okay, so let's first solve for fx of xy. Okay, so we're going to solve in relation to x, so we're going to treat y as if it is a constant. So each of the y is a constant, so if we find the derivative of that, that's just going to go to 0. Derivative of x is 1. Derivative of x squared is 2x, and derivative of 6 is just nothing. So there, that was pretty easy. That's f of x. And then we want to solve for f of x in relation to, we have our point, so our point is going to be, so our point is 1, 0, 9. So we're just going to take the x and the y, so we're going to have 1, 0, and we're going to plug that in there. So we have 1 plus 2 times 1, plug that in, and we get that equals 2, 3. Alright, nice, simple, good, easy, fun. Alright, so now let's do it with f in relation to y. So we have f of y of xy equals, so the derivative of e to the y is going to be, what is that? It's just going to be e to the y. Okay. And then the derivative of, and then x squared, and plus 6 are all constant, so they're all going to go to 0. So yeah, that's our answer for f in relation to y. And then we're going to plug in the point. So we have 1, 0, which is going to be equal to e of 0, which is going to be equal to 1. Alright, so now we have those points, and also from this point, and also because we have that point and it gives us oh so happily that 9, we know that f of 1, 0 equals 9. So we didn't have to do any math for that. And now we just plug and chug here. So plug this into this equation right up here. So we have I'm going to call this new tangent plane line, this new tangent plane equation, I'm going to call it g of x y equals so we have f of 1, 0, which is equal to 9 plus actually give me a sec. I'm actually going to move down just a little bit. I'm going to do it, just go down just a bit. Alright, I'm going to do it down here. Okay, so we have g of xy is going to be equal to, we have, so these are the three things we're going to be using in this and that. So we're going to have, 9, which is this right here, plus fx of ab, which is going to be 3 times x minus 1, which comes from this point right here. That's the x coordinate of the point around which we're finding the plane, plus 1, which is this right here, times y minus 0, which is this 0 right here. It's the y coordinate of the point at which we're finding this around. Oh, and hey, that's it. So let's simplify that out. And so now let's simplify that a little bit. We have gx of y equals 9 plus 3x minus 3 plus y. Let's go down just a little bit more. Simplify just a little once again. Y equals, add the negative 3 and 9 together, so we have 3x plus y plus 6. And there's our answer. That is the equation for the plane that is tangent to z equals ey plus x squared plus 6 at the point 1, 0, 9. So yeah, so it's actually, so like again I've said this in past videos and I'm gonna say it once again, is that these equations dealing with 3 variables in 3 space, they're actually, again, they're not that bad. They're just basically the same kind of rules that you're used to and the same computations that you're used to in 2 space. They're just kind of taken, there's just kind of an added dimension to them. Huh, pun intended. So yeah, so you just have to keep that in mind when you're doing it. Keep this equation in mind because that's important. Yeah, put a star next to that. So just keep that in mind, and you'll be all set if you just kind of keep your head about you. All right, so hope you guys enjoyed that short little video, and I will see you guys next time. You know I only you won't be alone. As long as I'm here, as long as you love me. Give me that old school love right now. As long as I'm here, as long as you love me. Give me that old school love right now. Whoa. Give me that late 80s, early 90s.